There is a fifth dimension, beyond that which is known to man. It is a dimension as vast as space and as timeless as infinity. It is the middle ground between standard and shadow, between SMPTE and superstition. We probe into time-quoted media and present a television station on a microscopic piece of sand. This is the dimension of imagination. It is an area which we call the future zone.
Good afternoon. Peter Symes. Education, Bachelor's of Science circa 1967. Occupation, consultant to industry. Peter Symes is an Emmy Award-winning patent-holding inventor, a fellow of SMPTE and senior member of the IEEE, published author of a book on video compression and contributor to others, including the NAB Engineering Handbook. If he looks familiar to you, perhaps you know him from his television career, which started in the engineering department of the BBC, or perhaps you know him as product manager for Philips, Central Dynamics, or Grass Valley. For 24 years, strategic planning, intellectual property, and technical liaison were his stock in trade. Or maybe you knew him representing Grass Valley to many organizations, including SMPTE, and then joining SMPTE's staff in 2007 as Director of Standards and Engineering, retiring only once SMPTE turned 100. Maybe that's why he seems familiar. Today, for us only, Peter Symes is a practicing prognosticator, here to tell us about the future of time itself. Beyond SMPTE timecode, the TLX project.
Thank you, Bill, very much for that introduction, and good afternoon, everyone. Well, the timing, as I said, I got my degree in 1967, and that's when I entered the television business. And in those days, if you wanted to edit videotape, which, by the way, in the BBC you were not allowed to do if it was a grade 1 program, you had to find where the magnetic stripes were on the tape by putting a EdiView on it so that you could see the stripes under a microscope and carefully cut the tape with a razor blade across to join it, and maybe it would go through the heads when you replayed it, and maybe not. It has been said that things got better in the 70s when they introduced electronic editing. I also know a lot of people who would disagree with that statement, but electronic editing was there, and they needed a way to label the different frames. And SMPTE picked up work that had been going on in the industry and created one of its very early television standards, which was ST12, ST12M as it was known for many years, SMPTE Time and Control Code. Came out in the mid-70s. That's over 40 years ago. It's still in universal use, not only in the media industry, but in many other industries as well, as a way of conveying time. It's a wonderful and durable standard that has put up with people messing with it for the last 40 years and adding bits on and changing definitions, but keeping backward compatibility, except when two companies decide they're going to use the opposite polarity of one bit for progressive, but this is life, right? But it is 40 years old. It has a number of deficiencies. And frankly, the criteria for choosing to do it the way they did it in 1974 are not things that are totally relevant today. For example, it had to be recorded on the control track of a quad videotape machine and of sufficiently low bandwidth that people could replay it when in spool. Its data format was designed with the fact that things like displays were really expensive in those days, and the electronics to do the display processing. So they chose BCD because that was the way that you had the fewest components to light up the Nixie tubes. Neither of these are compelling in 2018. But SMPTE timecode is still with us. It's still doing its job. So if we're going to come up with a successor, it's got to be something pretty special. Now, SMPTE timecode had the hours, minutes, seconds, frames format. They had to come up with this horrible thing called drop frame to cope with non-integer frame rates, which unfortunately are still with us today. So as we look beyond that, we have to have some fairly clever ideas to know what should be done. Now, back in early 2007, Hans Hoffman and I had a long discussion, and we recognized that actually there were two standards that were really getting hairy. One was SMPTE timecode, the other one was black burst for synchronization. And as we moved into a network environment, the idea of having to continually distribute black burst to everywhere in the plant, which is in itself a pretty ugly signal because it's got a very wide bandwidth, lots of DAs, this sort of thing, didn't seem like a really good idea. So we started a task force to look at new systems for both synchronization and time labeling. Asked SMPTE to come up with standards for these. Now, a lot of discussion went on in the task force and subsequently, and there's one factor which is really particularly relevant to both of these issues. We wanted to support all known frame rates in the broadcast industry, and certainly for the point of view of time labeling, we wanted also to come up with something that was still attractive for other industries. But the big thing on the synchronization was, well, what's the magic frequency that will make everything work, even if it's non-integer frame rates? And the brutal truth is there isn't one. You can kid yourself along and this sort of thing, but eventually, whatever number you come up with, somebody's going to come up with a frame rate that will break it. And I think it was Paul Briscoe who first sort of came up and said, well, look, so long as you've got enough precision in the signal, it doesn't matter. You can do the digital phase lock loop and generate any frequency you want. So that was the approach taken for synchronization. They picked up IEEE 1588 precision time protocol, basically with 1 nanosecond resolution, and proceeded to make a synchronization system out of that. Timecode didn't fare quite so well. There were two big exercises underway to generate a new time labeling system, both put forward by incredibly competent people. Probably either one of them would have been a very acceptable standard, but unfortunately they couldn't get consensus and, on one or the other, and things sort of degenerated a little bit with everybody thinking of their own ideas. So quickly, let's talk about some of the deficiencies. We want to support multiple media rates, including integer and non-integer rates. We want to support very high frame rates and very low frame rates. We want to support variable frame rates. If somebody hand cranks, it would be nice to be able to label each of the frames and know when they were created. We certainly don't want to be limited to a time span of 24 hours, but whatever we do, it's not going to happen in an instant, and we absolutely have to make sure that people have ways of working with both ST12 and whatever the new time code is. So some of us cast our mind back to a meeting we'd had an embarrassing number of years ago with a group of Hollywood post professionals, and they'd said, what we'd really like is a digital birth certificate, and by that we mean a precision time of acquisition, a persistent identifier, something that each camera or whatever has built into it and will say, tell us unambiguously that this stream came from that camera or whatever sort of equipment it is. And certainly it would be useful to have a media rate so that we don't have to wait for the next frame to know when to expect it. It would be nice to know what the rate is. So we put forward a project to say, let's do this. There at least is a simple, defined set of requirements we should be able to meet, but let's try and make it extensible so that if somebody comes along with wanting a different data item in there, we have a mechanism to add it without having to go back and modify the standard or even worse, start over. So those were the objectives, to come up with the 3 fields for the digital birth certificate and to provide a mechanism for extensibility. So we started on development of this in a group chaired by John Wilkie, and we had to look at the mechanism we wanted, or keep in mind at all times we wanted to make this extensible. We looked at the requirements of the digital birth certificate. We talked about ways to identify fields and looked at a KLV or a tag length value system, and came up with the fundamental item of this we called a TLX item. We called it all sorts of things through the way. The terminology is sometimes the most difficult. For weeks we were referring to it as a thingy so we wouldn't offend anybody who didn't like the particular terminology we came up with, but we eventually standardized on a TLX item, which is a data value, possibly with associated metadata, representing one data type. So it might be a time, it might be a source identifier, it might be a rate, and so on. And we said, well, okay, if we're going to have potentially a large number of these possible items as this standard develops, and we're making it extensible so people will be able to add new items, maybe we need a mechanism to say, well, in this practice, which items do we want to carry? For example, in a digital birth certificate, we might want to say that the timestamp, the identifier, and the rate are all mandatory, and we might want to make other frames optional, or we might want to say you can't have any other frames. So we came up with the idea of TLX profiles so that people who were using this mechanism to deal with particular applications could tune it to their own needs. So the structures, let's have a look at the structures. Still fluid, we're still working on this, and I must, by the way, thank Bruce Devlin, the Standards Vice President, for permission to present this paper. We don't normally talk and publish papers about stuff that we haven't done yet in the standards field, but he and I both felt this was worth exposing to a wider audience and getting more input, because we'd love to have more input from people who've got the expertise to offer here. So we decided we're going to need a TLX header, which is a special case of an item to define what the profile is. But generally speaking, any item would have an item identifier, which is probably a couple of bytes, the length of the payload, and then the payload as defined by that item definition. The profile, we trying to leave as flexible as it can be, because it's very much application oriented. There may be profiles that have got absolutely nothing to do with the media industry. In fact, rather hope that will be the case, that we will be attractive to other industries. It may specify some items as being mandatory. It may permit or not optional items. It may or may not constrain the total length of the label. And we can even, if we want to, and I'm not saying this one's useful, but just to give you an idea, if you want to create a profile that says you must carry item type A, A, B, C, and D are optional, but if you send B, you must also send C. And by the way, the maximum label size is 256 bytes. That's a very artificial example, but I want to give you the idea that, you know, a profile is not a difficult thing to define. You're just saying mandatory elements, optional elements or not, possibly total length, and you can even add rules that, you know, if this, then that sort of rules to define the profile. Maybe useful, who knows? So we're looking at a structure here where here's an overall label. It will have a 16-byte SMPTE UL to identify it as TLX. In general, if it's in some form of transport scheme, that probably can be dropped because the transport scheme will identify the payload as TLX. It will have the header, it will have a string of items forming the TLX data, and each of those will be a tag, a length, and a value, which may be just a simple value of something, or it may be a value with some metadata to tell you what particular aspect of that, or in the case of PTP time, it may have the data to show you the offset from PTP to local time. So when you define an item, it's perfectly acceptable to define some metadata to go with it to provide even more flexibility. And we will define a mechanism for creating new items. What we're doing is we're going to planning to have one document that defines the TLX system overall, another document that defines TLX items and which can fairly simply be amended by adding new items as they're defined, and a third document which will define profiles. And again, we'll start off with 1 or 2 or 3 as we publish the first set of documents, but there'll be a mechanism to go back and amend that to add new profiles as there's a need for them. To give you an idea of some of the things we're talking about, the source identifier, as requested by the digital broadcast certificate people, was something built into the equipment. We've considered it might be a MAC address, or it might be a value where SMPTE provides a block of values to a manufacturer so they can add them. And then somebody said, well, what about virtual machines that spin up and spin down? Well, maybe they use a UUID or something like that. But the idea there is fundamentally a numeric identifier. However, other people might want a totally different form of source ID that says, this is, unit 34, camera 3 in my organization, or they might even want to use it that this is camera 3 BERT for this particular production. So we will define, I think, a text-based identifier. We will certainly define a method of encapsulating ST12 data. So if you want to carry along something that pre-existed as ST12 data, you can just package that in a TLX item as the data and send it along with. And I'm sure we'll have other things as we go along. There may be alternative time formats and so on. We're also looking at other profiles. There will be an unconstrained profile, sort of default FF value that says, really no restrictions. Whatever you, just pass it and see what you find, because nobody's going to tell you what's going to be in here. And again, that actually may be a very useful option for many people. We haven't as yet started on defining storage mechanisms for it. Some of them are obvious. We're going to talk with the 2110 people to find out how best to bind this to a 2110 audio-video data streams. We'll almost certainly come up with a way of packaging in ST291 ancillary data. We've got my co-author on this, Hugh Reynolds, has come up with some very clever ideas of incorporating a span in the label so that it says, here's the time value for this label, and by the way, there will be 36 or 48 or 279 or whatever value frames or packets before you get the next label, so you're going to have to interpolate to get the value. And we see this as having possible applications in the audio field, but quite a useful thing to do anyway. And then we've also got to look at the fact that we'd like these things to be usable in XLL and JSON areas, so we probably want to have character representations and so on. And there's a load of work to be done there, but we've at the moment been dancing around it and decided, well, let's get our act together and get the system together. Well, bearing in mind the likely requirements, we're not trying to define the actual transports at this stage. So we're working on structures, we're working on how to use universal labels, and we'll be talking with the 30MR committee about that for their help there. We're looking at stream identification if, for example, an audio device might produce several hundred channels, and we might want some way of identifying, which channel of the device this came from. We looking at a general sort of instance concept to say, well, if there may actually be a need for example, an acquisition label that you'd like to keep for purposes of embedding in archive metadata, but when it comes to transmission, maybe you want this thing starting at 1 hour or starting at 0, has nothing actually to do with the acquisition time, and you probably don't want people to know which camera it came from and this sort of thing if it's going out in a more public environment. So we're looking at instance of, so that we can have, if necessary, more than one label associated with a stream. And under discussion at the moment, one of the things that Howard Luck came up with was, well, it'd be a good way of marking something that says, you really shouldn't change this field ever. Of course, people will, but it might be a nice thing to have there. And our document suite is going to be SMPTE 2120. We're working on it. I'm retired. I'm doing this as a volunteer, so is John Wilkie as the chair. We are very grateful to these companies who helped put up some money for us to get to the face-to-face meetings this year. That made a big difference and has helped us move along more quickly, so sincere thanks to them. But mainly for you guys, is it interesting? What I've described here is the current thinking. Nothing is immutable as yet. We've still got a lot of work to be done. If you've got better ideas than we've come up with, please join us. If you've got different applications, please join us. If you can write better sentences than that second one, please join us, but that would be a large group of people. We're under a drafting group under 32NF, the network committee, and John Wilkie chairs it. You can contact the chair with that email, and if you have things to say, especially if you've got nice things to say, we'd love to have you join us. But we've got some real good professionals who are the time experts and the broadcast experts and the post-production experts contributing to this, but we'd still like to hear other ideas, so if you've got ideas, please come along and join us, and thank you very much. You want to do questions now or later? Yeah.
So I'm quite certain that if we could get Rod Serling to read that second bullet point, it would be brilliant. If there are any questions, please approach the mic. I'm going to start off by asking whether Bruce gave us leave or expertise is sufficient to estimate a time frame for availability.
You really think I'm that dumb? We are hoping to have some documents, I would say, at least looking, going out to a wider audience, hopefully in the next 3 months. I think we've made a lot of progress actually in the last month. That now seems much more feasible. I'm sure we'll get much broader discussion once they first go out, but so I'm not even going to try and predict. But I mean, I would certainly hope that we have some standards during next year, but how early next year, who knows? Hi.
Andy Rosen, DSR doing software right. 12M is dead, all hail 12M. It is people who like factoring out prime numbers can find integer relationships between all these different rates. And the concept of a golden tick isn't false, it's just not widely embraced. And how small the tick is a matter of some debate. But there's no question that you can stick in 12M user data integer numbers that at least allow you to convey local time without having to do a jam sync. And that's what RDD46 is. So, and it's out there. It's published. The magic number, at least that golden tick, is now free for anyone to look at. So, is there now or in the foreseeable future a simple TLX profile that merely conveys local time? Maybe it's some nice high frame rates, and if indeed there is or soon will be a simple TLX use case that just conveys the local time, maybe for a variety of frame rates, then should some clever person come forward and, as a bridge from today into this metadata future, in your opinion, should some clever person come forward with a converter from a basic, just the facts, ma'am, TLX says the local time was blah, and then stuff it into 12M user data according to RDD46, so that at least we can have something like an end-to-end system that carries at least what the clock on the wall said through to the other end without drift and drop sync and all that other nasty stuff.
I'm not sure quite how many questions that was, but it was certainly quite a few. First of all, yes, for any given set of media rates, you can create a magic number. Unfortunately, people keep adding media rates. And we have discussions like integer or non-integer frame rates, which is interesting, as if, you know, broadcasters are very hot on that. Our competition can't even understand why we care. And, you know, we didn't want to restrict this to some set of rates. So you say carry local time. Well, that's precisely what we're proposing to do. If you take a PTP timestamp with 2059-2 metadata, that is local time. Now, it takes more cycles to display it than BCD. Okay? I'm sorry, that really isn't a problem today. And actually, when you come to it, if you think of adding together or subtracting two time values, it's an awful lot easier to add or subtract seconds and nanoseconds than it is to add or subtract frames. Now, wait a minute, which frame rate were we at, and did we have drop frame or not? And then having got the seconds right, we have to use 60 to get to the minutes, and then we have 60 to get to the hours, and then we have 24 to get to the days if we can actually go beyond 24 hours. PTP timestamp is actually a very, very simple way of doing that. And as I say, if you don't, we'd like this to be generally available, so we didn't want, as I say, to restrict to a fixed tick. Well, we have suggested a fixed tick, but using the same approach we did with 2059 of saying if your precision is good enough, it doesn't matter. You can work out whatever you want. And as we've used 2059 for synchronization, as 2059 is being used for in 2110 for transmission, it just seemed a very obvious way to do it. And yes, it's intuitively less easy, but to take a PTP value and display it as hours, minutes, seconds, frames, or whatever else you want is not actually a difficult thing to do. It's probably a little tiny corner of an FPGA, and it really shouldn't be a consideration today.
When those devices are built.
That's right. Well, there's a lot of PTP stuff around already. Now, the other point on that, as opposed to pushing it back into ST12, I will make a prediction that, number one, everybody will say, all right, if you really want to do that, that's a good idea, so long as you can find a chairman. And anyone who steps up to chair that body, go talk with Pat Waddell first, who's done the last few rides. It's not something that will get a lot of traction, I have to tell you.
Well, at least RDD46 is out, so
Absolutely.
There's a formula.
Yep.
Thanks.
Okay.
Thank you for watching. If you enjoyed this video, please tap the like button and also subscribe to our channel to receive notifications when we add new content. For more information about us, please visit SMPTE.org. We'll see you next time.